investor, faster than you ever thought possible. Call online.
Did you hear that? That was the sound of an AM radio signal coming from this cheap $2 or $3 high impedance earphone. And the only thing that's making it happen is a little 50-cent diode, a Prego jar with some wire wrapped around it. Note that it's Prego, not Ragu. It's not going to work if you use a Ragu jar. And some other wire. That's it. So the first thing that you'll need is an antenna, which is really just a length of wire. I'll talk more later about the appropriate length. There's a lot of leeway there. Turns out that the most appropriate length would be about 300 meters, which is way impractical, so you won't be doing that, I'm sure. If you follow this wire down, I've got a lot of excess slack here, but it would have been just as fine as if this wire had been inserted directly here. So this is the antenna. Every row on this breadboard, each of the holes or tie points in that row is electrically connected. So all of these wires right here are at the same potential, aka the same voltage, because they're in the same row. These wires are not electrically connected with these wires per se. They may be because of what's going on over here, but not because of the breadboard. So each row is electrically separated from the other rows and from the rows over here. So the current that's being, you can think of these electromagnetic waves as passing across the wire, and the electric field lines are pushing the electrons this way, and then they're pushing them this way. They're pushing them this way and pushing them this way. And for a station like KFI 640, that's happening at 640,000 times per second because the AM dial is in kilohertz. This is your inductor, often called a coil. It's just a whole bunch of turns of wire. This black tape here is just to keep the wire on the jar, but that's all it is, just a bunch of turns of wire. The number, I didn't even count it. It's not that important. Make it look roughly like this. So there's two wires coming off the inductor. The other one goes into this side, and then you'll see a second really long wire coming out of the breadboard, and that wire is to ground the circuit. And it's not important that it's a different color. I just happen to grab a second piece of wire that's not insulated. It's enameled, but you'll need to remove the enamel from the end of the wire. You can do that. Sometimes you can do it with a lighter, just torch the end, and then take an X-Acto knife or some sort of blade and scrape the remaining enamel off. This wire is pretty crucial to make such a simple AM detector work. I had a bunch of excess, so I wrapped it around here, but the important thing is that it's wrapped around the ground screw on the wall socket plate, because that screw usually is connected to a piece of metal somehow that's actually driven into the ground. If you have another way of grounding your circuit, that'll work, but this is easy. It should work. The diode, this will make more sense when I draw a circuit diagram, but the diode comes out of one of the ends of the inductor, and I've got it plugged into another tie point here, and also into that tie point or into that hole is one end of the earpiece. The other end of the earpiece is over here. I'll draw a diagram for all of this. But let me put this up to the microphone again here. If you've studied the radio circuits at all, you'll notice that there appears to be a missing capacitor. But it turns out that there's enough capacitance just in this jar alone to make it work. However, we can actually add a capacitor. This is a variable air capacitor. They're more expensive than your average discrete capacitor that you find in most electric circuits. I put a knob on it. I'm going to put this in parallel with the inductor, and you'll see that we can actually tune the circuit to different frequencies. And with this crappy little circuit, I'm able to get 3 local stations. So let me put this back up to the microphone here, and I'm expecting that, let me show you what I'm doing here. This variable air capacitor, when you turn it, you change the amount of surface area between these plates. There's this rotating set of plates, and then there's a fixed set of plates, and you can interleave them to varying degrees. When they're most interleaved is when you have the greatest capacitance. When they're apart, that's when you have the least capacitance. And as I'll discuss in a following video, greater capacitance lowers the resonant frequency. So I expect that when I've got this thing completely interleaved, the largest capacitance, that's when I should be low on the AM dial. You should be able to hear KFI 640 right about now. It might be quiet. Anyway, that one doesn't come in real clear around here. But now I'm going to slowly move the dial. I can't hear it myself, so ESPN 710 should be around in there somewhere. And then if I move the dial or the capacitor all the way to the other side with the minimum capacitance, that'll put me at the highest frequency on the AM dial, which is around here. It's the SPA in Ranch Cucamonga. And that frequency is over 1 kilohertz. More videos to follow.